morning, everybody. I hope you're all doing really well today. Today, we're going to continue talking about proportional relationships. We're going to tie everything together that we've talked about this week because we've talked about a few different things, and it might not be clear at this point how everything connects. Right, we've talked about tables, equations, graphs, and I know some of this stuff is new to you, but you're getting a little taste of algebra here, right? Just the beginning, but it's algebra in general is all about finding relationships between x and y, such as a proportional relationship. Right? We're always trying to see how whatever we plug into x, how do we turn that into y? And we're going to see that throughout this PowerPoint. And if you don't get that right now, it's okay. You're gonna be doing stuff like this for many years. Okay, I'm working with x and y. So let's get started. Okay, so let's look at this question down here that I wrote. It's not even so much of a question as more of a statement. Imagine Julie decides to go on a 2,000-mile road trip. If there's a proportional relationship between the number of miles she drives, we're calling that x, and the number of hours, y, then Julie is driving at the same speed the entire road trip. Whatever that speed is the same as our constant of proportionality, okay, or that k. Right? Remember, we've worked with y is equal to kx. We've also had k is equal to y divided by x. And you can shift things around in this equation. These are actually the same thing. Okay? So let's think about this a little bit. We have this table of data here that goes along with this question. Okay? So what we're seeing is that after after 1 hour, we're going 40 miles. So when x is 1, y is 40. Okay? And you can get the constant of proportionality by, well, either two ways. You can find y and divide that by x. So we could do 40 divided by 1, make us this 40. Or you can think about what times x gives you 40. Right? Just the opposite of division is multiplication. So if that's easier for you, think about what times 1 will give you 40. And well, it's going to be 40. If you do 60 divided by 1.5, you get 40. Or 1.5 times 40 gives you 60. So you can see either way will work. Now, I want to take a look at this a little bit more, this part of the table. So let me clear this. When we're dividing our miles over hours, or a y over x, we're finding the unit rate. And that unit rate, that's the same thing as our constant of proportionality. Okay? Our unit rate we're comparing to 1 in the denominator. And what I mean by that is, okay, let's look here. If we go 120 miles in 3 hours, well, if I want to know how far I'm going every 1 hour, I need to divide, and that tells me that I'm going every 40 miles per 1 hour. We have 1 hour in the denominator. So some other examples here. If you have a ratio of 4 cats to 2 dogs, Well, the unit rate of that would be 4 divided by 2, 2, and then we get 1. There's 2 cats for 1 dog. That makes sense, right? If we have double the dogs, we're going to have double the cats. If it's $6 for 3 gallons, right, you go to the gas station, that's how much you pay for 3 gallons of gas. That means that you pay $2 for every 1 gallon. Or if you have something like 16 pounds per 4 square centimeters, something like this would go along with pressure, air pressure, like in a ball. Well, if you wanted to find the unit rate, that would be 4 pounds every 1 square centimeter. Actually, I'm sorry, this should be a cubic centimeter. But it actually doesn't change the fact that this is a unit rate. We still solve it the same way. 16 divided by 4 gives us this 4 pounds per 1 cubic centimeter. So let's think about this table a little bit and what's actually going on. When Julie's driving here, we know after 1 hour, she drives 40 miles. Now, we know after 2 hours, she's going to drive another 40 miles, right? So after 2 hours, she's driven 80 miles total. But each hour, she drove 40 miles during that time. During this time, she drove 40 miles. So her speed is 40 miles every 1 hour. And the unit rate is 40 miles every 1 hour. So again, if we go 80 after 2 hours, well, 80 divided by 2 gives us this 40. Or after 3 hours, we went 120 miles. 120 divided by 3 gives us this 40. And you see that this pattern continues. Okay, so this is when we're thinking about it with tables. But tables go right along with equations. So we've also talked about in the IXL in my earlier video this week how to write an equation for a proportional relationship between x and y, okay? Especially when you're given a table. That's what we specifically looked at. So we already found out that our k here was 40, and we know to write an equation for a proportional relationship, it needs to be y is equal to kx. So we plug in this 40 here for this k. And that's, I'm going to move you all the way down here, but that's what we get, okay? So if we want to see how many miles we drove, well, we know if we're going 40 miles every hour, we need to multiply that 40 miles per hour times the number of hours we drive. So for example, if you're driving at a rate of 40 miles per hour, and you drive for 3 hours, well, you get 120. And that's what we saw here. And that's what we see in our table here. So that this equation, this goes along with our table. But this equation and the table also go along with a graph. Okay, this is a different way to think about it. Okay? So this is the same table here. I think I added a couple more to it, but it's the same idea. I took each row here and I put it on a graph like this. So we have after 0 hours, we went 0 miles. That's right here. Nothing special about that. After 1 hour though, so we have hours down here. After 1 hour, we went 40 miles. That's the second row. Now, after 2 hours, we went 80 miles. So 2 hours, 80 miles. after 3 hours? Well, we already found that. Actually, kind of skipped one here. This should have been 120 right here. Okay? But it's the same idea. You just need to match it up. So, anyways, if we keep going at the same rate, notice that we get a straight line here. Straight line that goes through the origin, goes through the middle. Straight line that goes through the middle, that's what a proportional graph looks like. So, I have a follow-up question for you here. We said that Julia was going on a 2,000-mile road trip. How many hours will she be driving for then, if she's always driving at this rate of 40 miles per hour? How long, how many hours will that take? Well, you should have gotten 50 hours. If you divide 2,000 by our constant of proportionality, that tells you that it'll take us 50 hours to go 2,000 miles. Or in other words, 50 times 40 will give us 2,000. Just like everything else, times 40 works. And then if you look at the graph, every time that, every hour we're going over, we're going up 40. After another hour, we go up another 40. So on and so forth. Just keep going like that. And it's telling us that for every 1 hour here, we're going up 40, we're going up 40 miles. Well, 40 miles are y over 1 hour x. Each of these little triangles gives you that same thing. So, as you move along in math, you're going to see more and more graphs like these, and tables, equations. That's what algebra is all about. What we're exploring right now are proportional relationships, directly related to ratios, equivalent ratios, proportions, and all that. Okay? So that's what we're talking about this week. Next week we're going to continue with proportions, but we're going to look at how we can use that to make judgments maybe about a population, and then we're also going to start looking at how we can use proportions to solve problems related to percentages. So there's definitely more to come. Hopefully you're finding these videos helpful, but that's all I have for you today. Just make sure you finish the Google form. It goes along with this video, so if you watch this, you should be okay for the forum. So good luck on that, and take care, everybody. Goodbye.